One of the best things about becoming a blockchain developer is that there's so many different unique ways to make money. Of course, you can get a job, you can make a freelancer, but there's all these other things you can do on the side to make money while you sleep, like buying and selling decentralized domain names. And in this video, you're going to learn how to code your own personalized, decentralized domain name marketplace. So before we get into that, if you're new around here, hey, I'm Gregory. On this channel, I turn you into a blockchain master. So if that's something that you're interested in, then smash that like button down below for the YouTube algorithm and subscribe to this channel. And if you don't know how to become a blockchain master step-by-step from start to finish, then head on over to dappuniversity.com/bootcamp to get started today. All right, so let's get into this. Let's talk about how to code your own personalized, decentralized domain name marketplace, okay? So, really quick piece of housekeeping, just addressing the elephant in the room. I am not feeling really well today. I've got this nose strip on, but I want to make videos on this channel, rain or shine, for you all so that you can become a blockchain master. And so here we are. But anyways, let's talk about the opportunity. So think about going back in time in the early days of the internet and being able to buy really high value domain names and just sitting on them for a long time and then selling them later once they become insanely in demand. Well, there's a similar opportunity on the table right now with blockchain-based domain names. We're going through the entire life cycle all over again, where people are registering domain names on a blockchain with protocols like ENS, which is the Ethereum name service, where basically you buy an NFT that resolves to an Ethereum address or even a website in this case, so that you're not sending cryptocurrency around to some hard to read user address. If you ever see your MetaMask address, it says 0x blah, 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 blah. You probably don't have that memorized. Well, instead, let's say your name is, Harold. You could just have a ENS name called Harold.eth and then resolve that to that address that you can't ever memorize. And so if you want to send cryptocurrency around and say, hey, yeah, just send me money to Harold.eth, that's way easier to remember than, just spouting off your address. So that's what ENS does. You can also do things like resolve those to websites. And because this is powered by smart contracts on a blockchain, you can create apps with this as a developer to interact with the ENS protocol to buy and sell domain names. You can also create your own custom smart contracts and mini website. So if you wanted to have a personal portfolio of domains, let's just say, again, your name's Harold, haroldsdomains.com, and let's say you had 10 really high quality domain names that somebody else might want in the future, you can essentially set a price for those domains on your website, and then other people can instantly buy them with cryptocurrency, and you can make a profit off of that. So that's what we're going to learn how to create today. And so what I'm going to do today, since I'm feeling so under the weather, is have my assistant Victor come on and present this video. Okay, so this is an excerpt from the Blockchain Mastery University program. So this will be a preview of the types of content that you get to see there on a weekly basis. So if that's something that you're interested in, then make sure you sign up with the link down below. So with that being said, let's jump in and get started.
We're going to build an ENS marketplace. When you connect your wallet to this Dapp will read all the ENS domains you own and allow you to put them up for sale on this ENS marketplace at a custom price. So you can put your ENS domains for sale at a custom price of Ether, and anyone can come into this buy ENS section and buy your ENS domains that are listed for sale. So we're going to build an ENS marketplace smart contract, and we're going to learn how to interact with the main ENS contract to be able to put ENS domains for sale and sell them at a certain price. And we're going to build this front end using React so anyone can use our Dapp. So if that sounds interesting, let's jump in. So what is ENS? ENS stands for Ethereum Name Service. It's basically this app where you can buy ENS domains. And what are ENS domains? These are basically replacement or other way to search your Ethereum address. An easier way to search your Ethereum address. For example, I can, instead of looking at an address on Etherscan, I can look up james.eth. And this ENS domain, and by the way, all of the ENS domains on ENS have this .eth extension. So if I look up james.eth, you can see that james.eth represents this address. And what we'll build today with ENS is we'll build an ENS marketplace where you can sell your previously bought ENS domains and other people can come in and buy them. And of course, this app is available on the main Ethereum network, but we're going to build our app on the Robson test network because ENS also has their main contract deployed on the Robson test network. So let me show you a quick preview of how this app looks. When you load up the React app, you're going to have this list and buy ENS options in the navbar. If you go to list and you connect your wallet, the app will automatically list all the ENS domains you own and allow you to list them at a certain ETH price. So if I want to list this ENS domain, all I have to do is put up the price of ETH I want to sell this domain at. For example, 0.1 ETH, and this ENS domain is just test domain 111.eth. If I want to list this, I just have to click on list ENS. So to list the domain, all we had to do is put up the price of 0.1 ETH or whatever you want, and then just click on list ENS. And if this MetaMask extension is slow to pop up, you can always click on the three dots and expand the MetaMask extension and just confirm the transaction. Select the transaction here and confirm them like this. After the transaction is successful, you get an alert like this from the React app that you have listed your item for sale. And once the transaction has finished, if you go to the buy ENS section, you'll see your ENS domain put up for sale at the price of 0.1 Ether. And how will this app work? So this app is of course deployed to the Ethereum mainnet, but also they have deployed this contract, or basically the entire app, on the Robston testnet, so you can test interacting and building dApps that interact with the ENS app on a test network. And this is what we'll use. So we'll not build on top of the Ethereum mainnet because we don't want to use real Ether for this app. So first we'll build the ENS name contract. This is the main Ethereum contract, the Ethereum marketplace contract basically, that has these functions like list ENS domain for sale and buy ENS domain. And this contract of course has to interact with the ENS main contract that will register and buy and transfer these domains from one account to another. And this contract is deployed to the Robston test network, and we'll also deploy our ENS marketplace contract on the Robston test network. And of course later we're going to build a React web app that interact with this contract. So basically the app we were using was this React app. So how can you buy one of these domains? So you can go to the app.ens.domains. This is the main app. And make sure your account is connected to the Robston test network and you have some Robston test Ether. This is where we'll buy our domain, and once we buy the domain, the app will show it to us and we can list it on our marketplace. So let's make sure we have some domain first. I've already bought some, but I'll show you how it's done. So you should just look up the domain, something like test domain 333. Because I've already bought the 111 in 222. You can search for this domain and see if it is available. All of these domains end up in .eth. You can see this one is available. So click again on the domain and you can register this domain for 1 year or 2 years or whatever. Since this is for test purposes, we're just going to do 1 year, and you need to click on request to register. This is going to prompt MetaMask, so this Dapp talks to the smart contract of ENS so they can link your account to this domain. This is the first step, to request to register. Then we have to wait for 1 minute. This is just so we can make sure that another person hasn't tried to register the same ENS domain after you just requested it to register. After 1 minute has passed, we can continue our buying. So click on register again. This would prompt MetaMask and ask you if you want to do this transaction. This will cost only 0.014 Ether. So click on confirm. This is of course test Ether. You don't have to really spend any real Ether. And once that has completed, we are ready to build our app. So to start building this app, we're first going to create a project, the front-end app. So to do this, we're going to say npx create a React app and then type in the name of your app, something like client or Dapp. This command should create a folder with React app, with Bootstrap React app inside, which will have similar file structure like this. Once this is done, open the folder in Visual Studio Code like I have done right here. And then inside this React app, we'll have the main, this is the main folder, the source folder. And inside here, we'll have an app.js file. And you can run this JS file. This is the finished app, but I'll show you step by step how I've developed this app so you can do it too. So you can run this React app by just saying npm start, and this should run the app on localhost on the port 3000. And now this is the front end part of our app, but we'll need to use Hardhat to create a Hardhat project inside our React app, and we can do this by just saying npx Hardhat and just choose a basic project, and then this will put the contracts folder and other folders inside your React app, and it will also put a Hardhat configuration file. And inside here we're going to install all of these dependencies here. I'm going to show you, and we're going to require this plugin that's from the company that built Hardhat, and this is like a bundle of all the plugins and packages that we use in Hardhat, like the Chai plugin for testing, like the Hardhat Eaters plugin from this company, etc. Also, we're going to configure this Hardhat project. We're going to configure the Rhapsody network to this Hardhat project, and we can do this by adding a networks object in here, and inside here we can name this whatever you want. I've just named it Rhapsody. And also in the package.json we have the .env package. This will allow us to have a .env file. I created this example file just so I can show you, and this is a secrets folder, file, where you can put all of your secrets like private keys and RPCs, and at runtime it will just inject all of these values inside here where we configure the Rhapsody testnet. So in the URL we have to provide the Rhapsody URL, and I've used Alchemy for this. I've seen that Infura didn't work for whatever reason, and also you have to provide the private key of your account to deploy to this network. So this is how an env file would look like. For this project, you're only going to need the private key to provide the private key and the Rhapsody RPC. So once these are configured, what I've done is I've moved the contracts, artifacts, the cache and test folder inside the source folder of my app. And I've created a new backend folder. Inside there, I've put my contracts folder. This is where all my contracts are at. Inside the artifacts should be all my artifacts. I have cache and the test folder. So if I go into source, you can see into the backend, I have some artifacts here, and I have all my contracts here. So let's see how I've developed this ENS Marketplace contract. I'm using the version 0.8.7. and I'm importing the ERC721 interface. This is from a library called OpenZeppelin, which is now the industry standard. So every project that wants to use interfaces and some other boilerplate contracts like the ERC20 interface uses OpenZeppelin. They are very secure contracts, verified by all of the Web3 community. And what this contract has, it has the count. First we store the count, or this is how we basically store all of the ENS domains. We store them in this mapping. Then we have a struct, which is item. This is basically our ENS domain. Then we have name, then we have the token ID. We have a boolean indicating if this domain is listed or not. Then we have a mapping that maps basically the item count to this item struct. This is public. These are called items. This is the main ENS contract we're going to interact with. It's still not initialized. It is public of type interface ERC 721. This is the contract we've imported from OpenZeppelin. And this is also immutable. Immutable means that it can only be initialized once in the constructor. Then we have the function list ENS. This function will allow you to list any ENS domain for sale. This takes in a name, a token ID, and a price. The price which you want to list your ENS domain at. The price should be greater than 0, and this is what we check with this require statement. Then we increase the item count. We do item count plus plus. This will increase the item count from 0 to 1. Then we use this item count to basically create new item in this mapping at this index. So basically at index item count. Then this is how you create an item from this struct. You just say item and then provide all the properties here, like item count, the name, token ID, and price. We get these passed in from the function arguments. Then we pass in true to this listed boolean value because this is now a listed ENS domain for sale. And then we pass in the address of the seller, which is the message.sender. This is the person who basically triggered this function. Then we have a buy ENS function. And this is the main function that transfers the ENS domain to the other person. So what we do here is we take in an item with this item ID from our mapping, and we do a bunch of checks. For example, if the price you sent, the message.value, or is equal to or greater than the price of the item you want to buy. If that's true, then we check if the item ID is greater than 0 or less than equal to the item count. Then we check if this is a listed domain, and we want to make sure that this is true. Then we interact basically with the ENS contract. This is the contract that we initialize here in the constructor. So you just say transfer from. This is a function that the ERC 721 interface has. So basically we just transfer from the seller to the person who triggered this function, who wants to buy this domain. This is the token ID. So this is how NFTs work. They have to have token IDs. Then we say that this item is not listed anymore. Then we transfer the money to the seller by accessing their address, then saying call. And call is a method in Solidity that you can also use to transfer ether, to call other functions from smart contracts. And also this may fail. So this is why we check this return value that we get from this call. And this is how you transfer ether. Just say in these square brackets, you just say value and provide the message.value. You get two return outputs from this call method. The first one is if the call was successful. This is this boolean value. Then we have a bytes. The second one is a bytes value, but this one we don't really need, so we can just omit this value by saying comma here, and we require that this is equal to true, or else we fail to send ether and we should revert the transaction. So that's basically the smart contract explained. It's pretty simple. Once you get the Robson address, you can look up this contract on the Robson Blockchain Explorer. And let me show you now how you can write the deploy script to deploy this contract on the Robson test network. So if you go into this backend folder inside scripts, we have a deploy.js. This is our script basically. And what we do here is we call this main function. This main function deploys the contract. This is boilerplate code from Hardhat itself. And in this main function, we get all the signers. This is an array. You can put in as many values as you want here. We'll just need the first account. With this get signers, we get all the accounts that are available to Hardhat, and we just print out the address that we deployed this contract with, and we print out the balance. Then we get the contract factory. All you have to do is provide the correct contract name, and then you'll get the factory contract. To deploy this, you just have to say contract.deploy, and this returns us a JavaScript object, which is a representation of this ENS name contract. And now you can call any function from this smart contract. Then we print out the address this contract was deployed to. And also what we have here is we have a function that takes in the JavaScript object, which is a representation of our contract, and an ENS name, basically the name of our smart contract. And what this does, it saves all the information from our smart contract that our frontend needs into this frontend file. So what it does, it needs to require the file system. It saves this into a variable. Then we provide the path where we want to save our contracts data. So if you go into the front end, go into contracts data, you can see what we do here. So it basically checks if this is the first time. If it is, then just create this directory, which is contracts data, in this file name. And this basically means the current place we're at. Then we say file system.write. What this does is, as you can see, it takes in two arguments: the path at which you want to create this contract, and then the actual file. How do we do this? We just save the contract address here. So what we do is we provide this in JSON format, and we say json.stringify. And then we also save the artifact ABI. How do we do this? We just provide the name of our smart contract, and we get the artifacts from this artifacts object, save it inside this variable, and just say json.stringify, and this will write a file, a JSON file of our ABI. And this is our file here with the contract name.json, and this is the previous file where the address of our contract is stored. So if we open this up, you can see it's only an address, and this one we actually loaded this from the artifacts in our deploy script. And now what you can do is to deploy this contract, you can basically create scripts inside my package.json. These are just short ways to combine multiple scripts at once. You can do all sorts of stuff, but I've named this script deploy, and you can run all of these by just saying npm run and then the name you provided here. So I have a deploy script that simply runs this deploy script by saying npx hardhat run and then the path of the deploy script. And basically this deploy Robson, it runs the deploy script but just on the Robson test network. Let me now show you how I've built the front end of this app. So all the front end stuff are stored in this front end folder. Specifically inside components, we have the main component, which is app.js. And here, of course, we need the information from our contract, like contracts data. And this is stored in contracts data folder. We have the two JSON file. This is just our address of our contract. And this is the actual ABI. And we can see, if I copy this and search for this, you can see where we use this. So this is our marketplace contract that we load in this load contracts function that we call when we connect our wallet. Also we have the check if wallet is connected function. So we basically check if the wallet is connected. You've probably seen this feature in all of the dApps. So if you connect your wallet once, you don't need to connect it again. And how do we utilize this function? With the use effect hook. And this hook is basically gets triggered, and we know by this sign, gets triggered when any time you refresh the page. And when you change your account, we reload everything. We set different account and we say window.reload. We reload everything. we basically reload the entire page, and what this does is triggers use effect again, or even if you just change the chain, different chain, because we need to load different ENS accounts if you do this. And this is the construct we interact with. We save everything inside state with React. So for this we use the use state hook. We have the account if it's loading, the marketplace, this is our construct, and the ENS construct. If we go to this ENS construct, if we search up for this ENS construct, you can see where we use this. Basically, we use the ENS construct address. This is the construct above inside this load constructs function. And for the markup, how do we design this app? Well, we simply have components. We have a navbar, simple navbar. With the connect wallet button, we have a logo. Then we have all the routes like by ENS. So we have two basically navigations. These are called routes. And inside here we have different components. Like the list item, this is the main thing that I showed you when we ran the app. And this is where all of your available domains that you own will be shown. And then when you basically list something for sale, we'll show you an alert that your item was listed. And here we call the list ENS function in our smart contract, the ENS marketplace smart contract that we've developed and deployed. And then if I go back to app.js, you'll see the by ENS component. This is where we show you in a grid. We show you, and you can see how the grid is built here. And we show you all the domains listed for sale. And finally, to run this app, we first have to say npx hardhat compile. This will compile all the contracts so that we can deploy them later. So we have compiled one Solidity file successfully. Now what we need to do is say npm run and deploy Robson. I've already shown you this command or script. It is stored in the package.json. It basically runs the deploy script on the Robson test network. So if I click enter, this shouldn't take a while. And for you to do this, you need to have some Robson ether in this account basically. As you can see, I have a bunch of ring.b test ether. So what I've done is this command has finished running. The contract was deployed to this address. So if you want to check this contract out, you can search this address on the ring.b blockchain explorer, and now we can run our frontend by saying npm start. So we have basically deployed the contract to the Robson test network. Now our Dapp has the ENS marketplace contract to interact with. Now let's go to localhost 3000 and check out our Dapp. So now if I load up my app on localhost 3000, you can see the app automatically loads all the ENS domains I own. So I bought these previously, and I also bought this domain in this tutorial. So let's list this domain for, let's say, 0.2 Ether. And to list this domain, of course, you have to connect your account first. So click on list domain. MetaMask should pop up. If it doesn't, just expand the view. Go open MetaMask in new tab, and you'll see in queue you have one transaction that is unapproved. Click on the transaction, and you should click on confirm. We have this loading screen that says please wait. Also, you have to confirm another transaction. After the two transactions have been finished, you should get an alert from Google Chrome that you have listed your item for sale. And if you go into buy ENS, wait a bit, you can see our domain is listed for sale for 0.2 Ether. And now what we can do is go into MetaMask and change to different account. So you can create a new account like so. I've already created one, and let's try to buy this domain from our Dapp. You should of course have some Robson Ether to buy this domain from our app. If we currently go into list, You can see I don't own any domains on this account. So this should change after we buy this domain. So click on buy the domain and confirm the transaction. After the transaction is finished, you can see congrats, you have bought the ENS. So let's go to list now, and boom, we can see we have successfully bought the ENS domain from our Dapp. So in this tutorial we've learned a lot. We've learned how to build a Dapp using React and how to combine Hardhat and React project. We've seen how you can use this file structure where in the deploy script you save all the front-end files in this front-end folder. We've seen how you can develop and deploy this contract, this ENS marketplace contract, and deploy it to the Robson test network where it interacts with the main ENS contract to list ENS domains for sale and buy them and transfer them between accounts.
All right, so that's an overview of how to create your own personalized ENS marketplace so that you can list domain names on your own site and sell them. So I hope you like this video. As always, smash that like button down below for the YouTube algorithm. Subscribe to this channel if you haven't already. And if you like this video and you want to take the next step and you want, you go for the throat, become a real-world blockchain developer, land your first six-figure job, I can show you how to do that over at dappuniversity.com/bootcamp. You don't have to be an expert to get started today. I've helped people with zero coding experience become real-world blockchain developers in a matter of months. So that's all I've got. And until next time, thanks for watching Dapp University.